complex numbers, aka imaginary numbers. So all it is I is just the square root of -1. Something that we don't really know what it is, but something that we can use mathematically to be able to like do some cool math stuff. So,
and sorry, just one tiny thing on that I think can be important. All real numbers are also complex numbers. So if on the test it asks, if on the CBC it asks you for all complex solutions, they might have I, they might not have I, they all count. So just keep that in mind for the CBE. If it says all complex solutions, that means real and imaginary.
Okay, so yeah, what I said was wrong. It's not just imaginary, it's both. Because you can write anything as, A plus B times I, or anything as a combination of A, B, and like a square root. Is that?
Because any real number, if you want to have the real number 5, for example, represented as a complex number, you're going to have A equals 5 and B equals 0.
There you go.
And then it's equal to 5.
Cool. But yeah, if it has an I, then it makes it the imaginary number. So if we square both sides of the first equation, that would get us I squared. It would be just -1, making the square root go away there. Okay, so to add and subtract them, we just need to add our similar things, so our constants like the A out in front with any of the square roots or things with I in them. So combine like terms there, and then just like it says, real terms with real terms, and then the imaginary with imaginary terms. Okay. You want to go over this?
Yeah. And so then when we are multiplying and dividing complex numbers, that's where it gets fun. Okay, but really so the multiply is exactly like you would normally think it is. It's just treat the I like you would any X and then combine like terms, multiply it, distribute it, combine like terms, you're completely normal. The only fun thing is when you get to dividing. And the thing is with dividing, you're going to multiply top and bottom because we're going to multiply the whole thing by 1 because we can't change what it is. But if we multiply top and bottom by the same number, it's the same thing. And we're going to multiply by the conjugate. The conjugate is specifically if you have A plus BI, the conjugate is A minus BI. Does anyone have any questions about the conjugate, what the conjugate is?
We'll show you what it kind of looks like in a second with an example.
Yes. But then the reason why we do that that's special is because then when you multiply the two, the negative is you're going to end up with A times BI minus ABI. So then those two terms are going to cancel. That's why it's special.
Yeah.
It'll make more sense when we do an example.
Okay, here we go. ¿Dónde está? So, if we were wanting to combine these two things together, first of all, the I on that side right now, it has like a 1 on the denominator, so we can't combine these together until they have matching things on the bottom. So what we're going to do is just write like a large 1, because you can imagine like there's a -1 in front of the first I. So another way of saying 1 might be, say, 2 plus 3i over 2 plus 3i. I chose that, so that way they have the same denominator. Turn the -I into a -2 plus 3i times I. So all we're doing is renaming that 1 out in front of there. So this part is our 1. So that's why I kept the parentheses around there, just to make sure that negative gets distributed. And then we keep this side the same. Yeah. Okay, so now let's just let's simplify this fraction first by distributing the negative. No, that would not be plus. That would turn into a minus 3i. And then we also have this second I out here, which came from our original I. So now it should be I squared, and then the I also needs to be the 2. It's the opposite of factor. Okay, and then now that we have the same thing on the bottom, we can combine the top and the bottom, the tops of the 2 fractions. So I'm going to do that by adding the 5 plus 3i. Is that clear? Are you
You have a question, Laura?
Why wouldn't we just multiply it by its reciprocal like we usually do?
So multiply by the conjugate?
Oh yeah, sorry, yeah.
Okay. So we are going to do that. They're two, like, it's going to end up being the same thing. So either you can combine like terms right now, which is what Megan is doing, and then you're going to multiply by the conjugate, or you can deal with this part first and then combine them. But it'll be the same thing.
Okay.
Yeah, so I'll need to multiply by the conjugate to get this bottom right here, like, better, so that we can combine like terms. Yeah. Okay, so on the top here, we have 2 things we can combine. We can combine this -2i and then this 3i. So I'm going to do that over here, so it should just be good I, and then minus 3i squared plus 5 over 2 plus 3. Now is when I'm going to do the reciprocal, or not reciprocal, the conjugate. So that means we are going to multiply by another special 1, but turn the plus into a minus. Okay. So remember that we are multiplying these 2 separate things. So that means we're going to need to make sure we're distributing and getting every single term. So this part on the top here has 3, and then another 2, so there should be 6 terms on the top. And then the bottom one has 2 and 2, so there should be 4 terms. Okay, so starting. Yeah, that's good. I squared. Do you guys remember what I squared is?
-1.
-1. So that just becomes plus 3. And then we can combine those together to 8. So that should be a little simpler. So there's just 4 terms on the top now. Thank you. Okay. Kind of running out of room here. So distributing the top, we have 2i, minus 3i squared, and now multiplying the 8, we have 8 times 2 is 16, and then 8 times -3 is -24i. Good. Okay, so this is what she was talking about with the magic of conjugates. The middle terms will cancel out. So 2 times 2 is 4. 2 times 3 is -6 plus 6i minus 9i. I did that a little faster, but if you do the bottom, that's what you should get.
Isn't it 9i squared?
Yes, it is 9i squared. Okay, so then this is where we're always going to see things cancel out of the middle 2 terms on the bottom. So those go away. And now all of our I squareds become a -1. So that turns this to a +3 and a +9. Okay, we're almost done. All we got to do is combine the things that are alike. So the things without an I, on the top we have 3 plus 16 is 19. And then we have 2i and -24i. So that's -22i on the top. And then 4 plus 9 on the bottom is 13. Now, that's good. But they like to put them in this form. So all we got to do is just split it back into 2 fractions. So we can write this fraction right here as 19/13 minus 22i/13. Because they're both being divided by 13, so why not just say it twice instead of all at once? And if this is our final answer, what would our A be? Sorry if that's...
19/13.
Sorry?
19/13.
19/13, yep.
And does the computer, when you enter it in, does it matter whether you put the I in the numerator spot or do you put it to the side of the fraction?
So I believe I am 90% sure that it doesn't actually ask you to put I term. It will ask you for what does
For
A
what
equal
A
and what does B
B
equal.
and not
To avoid that specifically.
And B is always the one that's with the I.
Yeah,
So for
but you
B,
don't
it
add
won't
the
add
I. Okay.
Yeah, so you don't put I, it's just B associated with that.
Okay.
Did I see somebody else who can?
Okay, is there a way that you could like really quickly do it?
Like where you
Or you start with a conjugate?
Yeah.
Yeah. we can do that.
Sorry.
It might actually be a bit easier.
That's what I was
Think of doing
thinking,
that.
but
Yeah, and both ways work just as well. So do whichever one you feel most comfortable with. If you like to combine like terms combine the fraction from the beginning, do that. If you like to get rid of the fraction first, do that. Well, it won't actually get rid of the fraction, we'll just make it a
We got that.
real number in the denominator.
There's, I wish it was like in the AMLAC where I could just,
You can?
let's do it on this page if that's okay.
yeah, that's
Yeah, this CBE doesn't have quite as many questions, so hopefully we have enough time for this. Actually, would it be alright if we did that at the end?
yeah.
Yeah, okay. Because sometimes these go over a little bit and I only want to keep the people who are interested. Okay.
Okay. So now this is just a true or false question. So it's just asking you the imaginary number negative square root of 4 times I is a solution to this equation. It's just asking whether it's true or false. Easiest way to do it, plug it in and see if it works. So we have x to the power 4. We're going to use this for our x. So then we're going to have negative square root of 4 times I. And then all of that is to the power of 4. And then we're going to minus 16. And we want to know if it equals 0. I'm going to put it over here because we don't know yet if that is true. And then we're just going to work with this. Okay, so now we have, so if we are multiplying things and they're all to the power of something, we can split that up. So I'm going to split that up into this is equal to negative 1 to the power of 4. That's where this negative is coming from. And then we're going to have square root of 4 to the power of 4. And then we're going to have I to the power of 4. Okay, and then all of that minus 16. Okay, so negative 1 to the power of 4. That's just going to be 1. Okay, so we have 1 here. And then square root of 4 squared. What's that going to be? Somebody really fast.
wait, what?
The square root of 4 squared. I'm going to split 4. And so then 4 squared again to get to the power of 4, 16. I heard somebody say it. So we have 16 here. And then I to the power of 4. So remember, I'm just going to do this off to the side.
So the power of 4 means you can square it and then square it again. It's 2 plus 2.
Yes, thank you. So yeah, so that's what we're doing. So then that is a very good clarification. So I to the power of 4. This is what I was doing. Is this squared and then squared again. And then you can multiply those. And then it says those two are equal. That is what we are doing. And then we're going to do the same thing with I. So I squared equals negative 1. So negative 1 squared just equals 1. Okay, so we have 6. So 1 times 16 times 1 minus 16. So then 16 minus 16 equals 0. Wow, so it's true.
Where's the my? Oh, okay, that makes sense. Never mind.
Are we all good there? Any questions? No? Okay, then we're gonna move on.
If something is a solution to something, that means that x equals it. So just plug it in and check and see if it works. Okie dokie. Looking for all the complex solutions to the equation. So like she said, that includes real and imaginary numbers. So first we're going to distribute. And then we're going to make it all equal to 0. And then we can use the quadratic formula. So,
Sorry, just by the way,
mhm.
this quadratic formula, it says -2. It's supposed to be -4. That's just,
I did not notice that.
I noticed it because I was doing it earlier. And I tried it in the formula and I got that answer.
That is a bigger. Okay, so how I like to distribute, as I was doing earlier, is I take the first one times the first one of the second one. So I'll just draw it out. X squared plus 2x. And then the second one, we go plus 1x plus 2 equals 1. Okay. So now we got to move that 1 into this equation here so that we can set equal to 0. So just subtracting 1 on both sides. Subtracting 1 from the 2 here, we should just get 1. And then we can also combine these x's together to get 3x. Okay. Yes, and this one we should need the quadratic formula. If you know how to factor and you feel confident in it, go ahead and do that. Because it's faster. So, but if not, just put it into the quadratic formula.
Yeah, this one ends up being super messy to factor, so just don't even try.
Yeah, there's nothing.
Sorry, could you go over what happened to what you did with the 2?
The 2x or the
why there's no 2 and you have the 1 instead?
Yeah, because we want to set it equal to 0 because it needs to be like that before we can use the quadratic formula. So all I did is I subtracted this 1 on the end, and I subtracted it from here. So 2 minus 1 is 1. Good question. Okay, so before we use the quadratic formula, we need to know what our ABC's are. So right here, there's nothing there, but you can imagine that there would be a 1 because it doesn't change anything. So A would be 1. B would be our second coefficient, the one in front of the x. And then C is just whatever number is being added on, 1. So the order doesn't matter, it's what the numbers are with. A is with the x squared, B is with the x, and C is just by itself. Okay, so now according to the formula, right here, plugging it in, x is -3 plus or minus the square root of 3 squared minus 4 times A times C. Oh, good. That's nice. And then all over 2 times. The thing I always like to simplify first is whatever's under the square root, because usually it's a little bit complicated. This is pretty easy though, because we have 2 1s. So 3 squares 9 minus 4 is 5. And then all over 2. And I believe that is all the solutions. So how you would type this in your CBE is this plus or minus here means that there are 2 options, one that's being added and one that's being subtracted. So you would just write it as -3 plus the square root of 5 over 2, comma, -3 minus the square root of 5 over 2. Okay. Yeah, these are all the solutions to this equation.
Any questions about that before we move on?
Yeah, with the quadratic formula, if b is a negative number, would you put it still as negative b at the beginning, or would it be just regular b?
So since b is negative, it's like negative, -1 would be +1. But it's because of that negative b. So it's always negative b, but you're right, if b itself is negative, you're gonna end up writing a positive number.
Yeah, negative times negative.
Equals positive. Yep.
Question. Also, if we ended up with a negative inside of the square root, say it was -5, that means we can pull out a negative square root of 1, which is I. So you could write this as -3 plus or minus, let me write this. -3 plus or minus the square root of 5, because we pulled out a -1. Like this. But we can just write this as an I all over 2. So that's if you had an imaginary.
Yeah, and so this is a perfect example of complex solutions. So we ended up with 2 real numbers. Those real numbers are complex solutions. They still count. Everything counts. Okay.
If the product of two or more numbers is equal to 0, then at least one of the numbers must be to 0. I mean, 0 times anything is 0, so this makes sense in my mind. If something's equal to 0, and you got A, B, or times C, then either A, B, or C has to be 0, or maybe both A and B are 0. But you know, at least one of them.
Yeah.
There's no other way to get it, so we're going to use that.
Okay, and so now we're going to determine all the real number solutions to this rational equation. So that means in this case, we don't, if it's imaginary, we're going to throw it out. We are only looking at the real numbers. You have to read the question. Okay, so in order to do that, first I'm going to take this. There's a lot of words here. I wish I could get rid of them.
Is the next slide?
And then the next slide has the answer. I checked earlier. I don't want to put it because then I'll put the answer wrong. Okay. But I'm pretty sure. Okay. Yeah, just ignore that. Okay, so first I'm gonna look at this. So this term here, I'm just gonna do it here because of the space. So this is also equal. You can factor an x out of that. So x times x minus 5. Okay, so we have this x minus 5 in both of the terms. So we're just gonna keep that in mind because it's gonna make it easier when we're multiplying. Okay, so we want to get rid of these denominators because the denominators are messy. But when we do that, we have to remember that we might end up creating some solutions. The reason, for example, I'm going to look right here. So this x minus 5 cannot be equal to 0 because otherwise you're divided by 0 and that's not defined.
Math explodes.
Yeah, math goes boom if you divide by 0. You can prove that 1 equals 2. It's really fun, but I'll do it another day if you're interested. Anyway, but yeah, don't divide by 0. So we have to just like kind of keep this off to this side and know we're going to have to check our answers at the end.
That's the last step.
Yeah, that's right. That is very important.
So if we end up getting a x equals 5 or an x equals 0, that would make the denominator 0. Because if you plug in 5 right here, then it becomes.
Also, checking your answers is always good because we're not computers. We make algebraic mistakes. And so if you turned a negative into a positive sometime along the line, checking your answers will help. So I have lost so many points on tests because I did some algebraic error and then didn't check my answers at the end. So just check your answers. It's good. Did you have a question?
No.
Okay, sorry, I thought you said hand. Okay. So now with that long spiel, we're going to take all of these and we are going to multiply by this factor because we're trying to get rid of the denominators. And then we're just going to come back at the end and do that. Okay, yeah, and so from this term, we can also have x is not equal, so x can't be equal to -5, and then also x can't be equal to 0 because that would make this term 0. So we're just going to have those off to the side in case we need them later. Okay, so now we're going to multiply everything by this term. So that is going to give us 3x over x minus 5 times x minus 5, x times x minus 5, and then minus 39 times x. What's that? 36.
You can just use the back of the pen.
Oh, that is very good to know. Thank you. Okay. Times x minus 5. And then still here, x minus 5 equals 2 x minus
So
5.
you know why we chose x times x minus 5. It's the denominator that has the most things in it. So that is like our goal. We want everything to match up with the same denominator. So we're going to make the biggest denominator the same across the board. It's easier to multiply than to.
Thank you. So that is exactly right how Megan said it. I should have clarified that.
So she multiplied each one by our ones. The x minus 5.
Yeah, I started doing that and then I realized that I didn't know that that didn't make any sense. So we just have to multiply them all by the same number. So we are multiplying every single thing by x minus 5. And since we did it on both sides of the equation, it's going to be equal. We're multiplying left and right by the same thing, so we're good. Okay. Yes. Okay, so then that is, yeah, so let's already have that. And then this is going to cancel out with this. This is going to cancel out with this. This is going to cancel out with this. And those two just stay there. So then that is going to give us 3x times x. 3x squared minus 39 equals, I'm going to go ahead and distribute this. So 2x times x, 2x squared minus 10x.
This is so much easier than the way I did it. I'm glad you're doing this problem.
Cool. And you,
Oh,
yes.
sorry, where did the 2x on the right side of the equal sign?
The 2x squared?
No,
Or the
just
2x
2x
above
times
that.
x minus 5.
Okay, so this is actually 2, so we have this 2 here.
Uh,
And then we multiplied everything by x times x minus 5.
oh, 2 is on, I got you. My bad.
Yeah, I just like didn't write the multiplication sign because it was
Yeah.
like, yeah. But that's where that came from. Does that answer your question?
Yep.
Okay. Any other questions before we move on? No. Okay, then I'm going to put everything on one side so we can have our zeros and we can use this fancy 0 rule, which is what we wanted in the first place. Okay, so we're going to minus 2x from both sides, 2x squared, and then we're going to add, so this is negative, so in order to cancel it, we're going to add 10x to both sides. Okay, so minus 2x squared. I know you can hardly read this, I'm so sorry. It's because there's so many words on this page. Okay, so 3x squared minus 2x squared is going to equal x squared plus 10x. And then
Minus 39.
exactly. Okay, and now we are going to factor this.
But what's on this side?
Okay,
0.
thank you. Okay, and so we're going to use a special 0 thing. We're going to factor it, and then one of those parts is going to have to equal 0. The way that we're going to factor is we are going to look for two numbers that multiply to equal negative 39 and add to equal plus 10. that is what you're looking for in the factors. If you have questions with that, I can explain in more detail. If not,
Yeah.
we'll just keep
You
going.
can also use just go straight to the quadratic equation,
Or you can use that.
whichever one you're more confident on.
Yeah.
Yes.
Are there any numbers that multiply to get 39?
There are, and I happen to know them off the top of my head, and I can tell you. Or you can, yes?
Is it 13 times 3?
Exactly. So 13 times 3. And so the reason, so we're going to have 13. So I'm going to have x, and then we're going to have x. So a big clue here, some things that help me when you're looking for numbers, because I don't like the quadratic formula. In all honesty, I avoid it whenever I possibly can. I just don't like it. If I can factor it, I factor it. So some things that you learn to look for, this is negative. In order to have two numbers that multiply to equal a negative number, one has to be negative, one has to be positive. So I'm going to go ahead and put a plus here and a minus here. We don't know which one is which yet, but one of them is negative, one of them is positive. And then we're just going to start looking for things that, since one of them is negative, one of them is positive, it's actually going to be the difference that equals 10. As you, sorry, what was your name?
Me?
Yeah.
Evan.
Evan. As Evan so kindly pointed out, 10 and 3 work perfectly. I mean, 13 and 3, sorry. And so then we want this 10 to be positive. So we're going to make the bigger number positive. So here's our 13 minus 3.
13 minus 3 is 10.
Yeah. Everyone good up to there?
Sometimes you might see the method where you draw like a big X and you put this number on the top and that number on the bottom. I don't know if you've seen that before, but that's one way of organizing it.
Yeah. Yes.
So say there's like, when the 39 is like a 37, we have to use the quadratic formula for that?
Yeah,
Probably.
because
I
that's
don't
like
know.
a prime, so there's, yeah. So
So,
it's,
Well,
oh, sorry. If you did the quadratic formula, would the A be 1, B 10, and C negative 39?
yep,
Is that
exactly. Yeah, the one exception, if it's like 30, so in this one you would have to use it if it was like x
was 36.
plus 36 minus 36x minus 37.
You could do
Well, then it
one.
works. Because then you can have 37, positive 37 minus 1, and it works. But 37 is prime, so there's no other factors. So, good up till there? Okay, so we're going to use our special magic 0 rule because 0 is epic. And we're going to set both these things equal to 0. And we're going to figure out what, because we know that either this is 0 or this is 0.
Because those are the two things, two chunks being multiplied.
Exactly, or both. Because there's no other way we're going to multiply these things to equal 0 if they're not one or the other, both equal to 0. Okay, so x plus 13 equals 0. That means that x equals 13.
Negative.
Negative 13, thank you. This is why we have two people here. So if one of us makes a mistake, we can catch each other. Okay. And then x minus 3 equals 0. X equals 3. Okay, so here are our two solutions. And then you're going to go back. You're going to plug them in and check the answers. Or you can also, we looked over here. So this is going to end up being x is not equal to 5. And then we know x can't be equal to 0 and x can't be equal to 5. Luckily, neither of these are 0 or 5. So we're good. As long as we did our algebra correctly, which I happen to know we did because I have the answers, but I recommend just go back and plug it in and check the solution anyway to check for algebraic mistakes. I'm not going to do it now though for the time.
So if we somehow got x equals 5 here at the bottom, we would not list it as one of the answers because then we would be dividing by 0. It's called a hole if you're graphing it. It's just and there's something a hole in it. It's like can't do that.
Yeah. Because this is the most important equation. This other thing that we found is like mostly the same, but it takes out the holes as she's talking about. So it's not. This is the important one. Look it back into that one.
Hey, got it. Okay. Let me just I want to see like how much questions we have left because
We have a total of 10 questions.
10 questions.
Yes.
Okay, and that's 1 part. Okay, so we go a little bit faster. All right, so from that point we have. Okay. Oh, look at that! It's just like the last problem we had, except it's already into chunks. So that means that this could be 0, this could be 0, or this being 0 would make this true. So I'm just going to set each of them equal to 0. 4x plus 8. Okay, so then what we do is you square both sides to get rid of the square root. 0 squared is just 0. Okay, and then subtract an 8. 4x is equal to -8. And then dividing by 4. -8 over 4, which is the same thing as -2. Okay, so -2 is one of the things that we could do. And I'm going to erase this real quick. Sorry. Okay, so then for the next one, this is a quadratic equation because it has a squared in it. So we can use the quadratic formula to find this one, or we can factor.
This one doesn't factor.
Okay. So what would our A, B, and C be in this one?
3, 2, and 2.
So x is -2 plus or minus the square root of 2 squared minus 4 times 3 times -2. I've used this too many times. Cool. Okay, but make sure when you're doing it that you are being careful because you don't want to do a silly error and plug it in the wrong thing. Okay, so now we're gonna simplify under the square root. So 2 squared is 4, and then 4 times 3 times -2 is -24. But we're subtracting it. Subtracting a negative number. So that means it's going to be positive 24. 4 plus 24. I did that a lot louder. And then 2 times 3 is 6. Okay. And you don't need to simplify your answers. Fun fact for the CBE, even if it says to simplify, it'll take anything that is still the correct answer. So these are 2 other real number solutions that you would be putting in as your answer. I'm just going to write it like this.
Wait, did you just say you don't have to simplify that on the CBE?
Yep. You don't need to simplify anything, actually, even if it says to simplify.
But if you wanted, then you could simplify it by pulling out a square root of 4. So 28 could be factored into 4 times 7. And so then you have square root of 4 times square root of 7. And then 2 times, yeah. And then you can divide everything by 2 and simplify it if you feel like it. If you just like pretty numbers, it just depends. I'm glad somebody found that funny besides me.
Okay. So then the last thing we're going to see if this one is. I really don't like the extraneous circumstance for this. We'll get to that in a second. So for this one, we have 1, 18, and 5 for our A, B, and C. -18 plus or minus the square root.
This one does
18.
factor if you feel like it.
Oh, it does?
By
Okay,
the
let's
way.
practice that. What are 2 numbers that, let's just think of the factors of 45. Well, we got 1 and 45, but I don't think those are going to add up to 18. or subtract?
15 and 3.
15 and 3. That looks very promising because you could add those directly to 18. Just for the sake of it, you could also do 5 and 9. Okay. So since we're getting a positive 45, that means either they're both negative or both positive. But since we're also wanting to add to 18 with those same numbers, and I'm guessing they're going to be positive. Because
By guessing, she means mathematical genius.
sure. Because 15 times 3 gets us 45, and then 15 plus 3 gets us 18. Because that's what happens when you would FOIL this out, right? Because you'd be multiplying these two things together, but then you would have two terms that have an x in them, and you'd end up simplifying and adding them together. So that's why you can do that with factoring. Fun fact. Okay. So to make this equal to 0, then x can either be a negative 15, that would make this part 0, or x could be a negative 3. But, here comes the but. So, see how it says check for extraneous? That's because there is another rule besides dividing by 0 that we don't want to consider because we're talking about real solutions. So that means we don't want any negatives in the square root. So once you're got all of what you think are the solutions, what I would do is plug them into a square root if you have one there, and see if that makes it a negative on the inside. So if you do negative 2, we should get 0 because that's the first thing we solve for. If we do the other one,
Square root of 0, you're fine. Square root of 0 is just 0.
Yeah, square root of 0 is okay. Yes.
Just can't be negative. Because there's some people who have had questions about that.
How would they plug in this into the square root? Would they just kind of think if this is a positive or a negative number? Or
I'm just guessing the that solution, negative 2 plus or minus the square root of 28 over 6. Because it's plus or minus the square root of 28. I'm guessing it's the plus that's good because I'm guessing the solution is positive, and the one where it's negative 2 minus the square root of 28, that solution is negative. So I'm guessing that second solution is not real. It's
Maybe.
not right, but the plus is.
That's a good guess. But the just whether it's positive or negative isn't the only thing that to consider. Is 4 times it greater than 8? Or
so it's whether
if
it's
negative.
Okay.
Yeah, it's whether it's more or
Sorry.
less than the square root of 2.
Yeah.
But more than less than, yeah. But another way you can look at this, because those are weird and complicated, is so we already solved that if x equals negative 2, it equals 0, right? So if you plug in a number bigger than negative square root of 2, is what's inside of that going to get bigger or smaller? It's going to get bigger. So we can kind of just reason, it's like if negative 2, if x is greater than negative 2, then we're good. If x is less than negative 2,
We're good inside the square
bad.
root. Okay. So if you just figure out what these two are, then if they're greater, then we're good. And they are. But unfortunately, when you put in negative 15 or negative 3 into the square root here, then it's going to become negative. So that means they are not real solutions. So we're going to put them away. There are 3 solutions.
And
Wait,
that
how do
2,
we
Wait, what
check?
was the third
that 2
one?
is supposed to be negative, it's just a typo. But it is negative 2.
How do we check that the negative 2 minus square root of 28 over 6? Would you plug it back in?
That's what you could, but that's a lot of
Yeah.
hard typing. So what we were saying is that since we know within here, negative 2 is the threshold of, that's when the square root is 0. That means on the other side of it is going to be negative.
Oh,
And then on this side of it, it's gonna be positive.
So then instead of plugging it in completely, you're just trying to figure out if this number is greater than or equal to -2. And we can do that real quick.
If you plug both of these into your calculator and it's greater than -2, then we should be.
Yeah.
Okay.
Or you can also, like we did it before, so we figure out you can simplify that. If you simplify it, then you can get a better approximation. It works out to be -1 plus or minus the square root of 7 all over 6.
Okay.
And so -1 of
3. But yeah,
over 3. Thank you.
Yep.
But
it
yeah.
doesn't really help you with typing in things, but
Well, but I'm saying anyway. But if you have that, then you can estimate easier. And then you don't have to type anything in. But anyway.
Okay. Thank you.
if you don't have any square roots to deal with, then you don't need to check any of that.
Cool. Okay. Okay, so determine all the complex solutions to this equation. Okay, so we're looking at this x to the 4 minus 8x squared equals 20. I'm gonna move this over so that we have a 0. X to the 4, or forgive my handwriting. This board makes my handwriting even worse than it normally is. Okay. Minus 8x squared minus 20 equals 0. Okay, so we look at this and then we're like, oh wait, this is an x to the power 4, it's not an x squared, I don't know what to do. So then we throw our hands up and we cry and we say that we'll never do math again, right?
Or we do something to make it into an x squared, and then we know how to handle it.
I think that Megan's a lot more intelligent than I am. So we're going to do that because just giving up on life, probably not the best plan. Okay, so we're going to realize it's like, hey, if this is x squared, then x to the 4 is x squared squared. So x to the 4 plus x squared squared. I'm like, hey, that's kind of like an x and an x squared, right? So I'm going to just make up this number u because it's just a variable. It's just a placeholder just to help us think. So we're going to decide that we made u so it can be whatever the heck we want it to be. And I'm going to decide that my u equals x squared. Okay, so then I'm going to plug that in and substitute it. So as we just decided, it's like x to the 4 is x squared squared. So that gives us u squared minus 8 times u minus 20 equals 0. Look at that. Now I have a quadratic. So.
You guys digest that all right? Cool.
Yeah? Okay. So now we are going to try to factor this. I do not remember if this one factors nicely.
It does.
It does. Yeah. Yes, it's okay, yeah. Thank
What
you.
is it?
Negative 10
It's
and 2.
negative 10 and 2.
Negative 22? Okay.
10, yeah. X times. Thank you very much.
Negative 10 times 2 is negative 20. The negative 10 plus 2 is negative 8.
There we go. And that equals 0. So then we have u minus 10 equals 0. And u plus 2 equals 0. But remember, we didn't care about u. We want to solve for x. So now we're going to plug it back in. So we're going to have x squared. I'm just plugging in for u. Minus 10 equals 0. And we're going to have x squared plus 2 equals 0. Okay, now we just have these two things. So x squared, we're looking for complex solutions. Okay, so it could be imaginary, it could be real, it doesn't matter. Okay, so I'm just going to look at this one first just because. So x squared plus 2, that gives us x squared equals negative 2. So then x is going to equal plus or minus. That is important because whether it's, Yeah, because you're taking the square root, so it could be plus or minus. Both are going to equal x squared of -2, which equals plus or minus the square root of 2 times I, because it's -1. Does that part make sense? Okay, then we can do this part. So then that means that x squared equals 10. So then x equals plus or minus the square root of 10. Okay, so we didn't do any weird things, so we're not going to have extraneous solutions. You can still plug those in just to check your algebra, but all the solutions will work. Yes.
Is it plus or minus 2i just because negative under the square root?
Yeah.
Plus or minus.
Yeah,
Yes.
because there's a negative, that means that it is an imaginary number. So we can take out the negative, square root of -1.
This
And
question is
just
just
call it
worded
I.
weird.
Yeah, it is weird. I'm sorry.
When I first saw this question, I was like, I don't know what to do. But then you
I
did this little
think
trick.
But just to clarify, the I is outside of the square root of 2.
Mm-hmm.
It's not inside. Yes.
I think just what's tripping me up is why did it have this? I know like solving for u to begin with is kind of to help with understand the equation, but just having that extra step in there kind of was just like.
Yeah. And I mean, if you can get here, like if you can factor without substituting for u, then just do it.
What he's saying is like, in here it's saying that we shouldn't just stop right there. We should just solve for u. So x is equal to, like.
No, I'm
No?
just saying like solving for u was just felt unnecessary almost. So
Yeah, can we do this without putting u in?
You can. You can just go straight. Okay, so we're gonna have it over here. So it just depends on what the solving for u helps some people feel more comfortable because it's
You can
weird.
only factor
Cause-
use the quadratic equation with a quadratic
Well,
square root.
yeah, you can only use the quadratic equation. You can factor, but a lot of times it just freaks people out. So then it's easier or more comfortable to put it back into a quadratic. But if you look at it and you're like, hey, I know how to factor that, then just go ahead and do it. And so then you can do the same thing. You'll end up with, you'll just look and it's like, okay, I want this to be, so we're going to have 2x squared instead of 2x's.
Yeah.
And then minus.
This is way less scary than the u.
Okay. Yeah.
And just do
Okay.
this.
Yeah, just put x squared instead of x.
Yeah.
Okay.
And you end up with exactly the same thing. The u is just if it feels more comfortable. If it feels scary, then just ignore it. It doesn't matter. I've never used the u until I was teaching this class. So whatever you feel comfortable with.
I get the u's to visualize the x squared, but like it's like not an x squared, but like it just didn't make sense to me.
Yeah, and that is totally valid. Everyone's brains are different. So if it doesn't make sense, then just ignore it. You don't need it.
Functions. Okay. So whenever they're asking for the domain, what they're really asking is like, what can we have x be in a function? Because like normally when you're graphing something, right, you can just have any x on there. But sometimes the function looks something like this, where it never actually reaches whatever is on that line, whatever that number is. So technically that would not be in the domain because it's like there's a abyss there. So the two things that make that happen are dividing by 0 and square root of -1.
Or anything
We've been
you know.
talking about those, right?
And piecewise functions. Those two.
Piecewise functions.
Uh-huh.
Oh yeah, because if you're just talking about x plus 1 is greater than 3, well then we're talking so it's greater than 3. Okay, yeah, that makes sense. So yeah, what can we actually put into this function? In this, we're just given a bunch of points. So what are we putting in for x? Well, we're putting in a -1. We're putting in a 1, this, so on. So that is our domain.
Yes.
If one of the ordered pairs has the same value for x, so you only have to write it once, right? So like,
Yes.
I
okay.
think so.
Well, okay, so actually that wouldn't be a function. Because part of the definition of a function is that every x only goes to one y. That could be a relation, and so it would be part of the domain for the relation. But here we're told it's a function, so you can only have x one time. Like each x can only go to one y.
Okay.
This is not a function.
Good question. Okay, so now it's really hard to write all of the numbers that x could be. So we use this notation just to say like the ranges that it could be. So say it keeps on going on and on to -50. Then we will start with this. Now, as you see up here, if it's a parenthesis, that means whatever is written next to it, we're not actually including it. Because -infinity isn't actually a set number, it's more of a concept. So we just, whenever you're dealing with infinity, it's a parenthesis, positive or negative. Now, if it's a bracket, that means we are including that. In this case, see how there's a hole right there on -2? It's a hole representing that we are not actually including the -2. So we're going to use a parenthesis. As it says right here, we connect them with a U because we're having the union of the two ranges, putting them together. And then this one right here doesn't have a hole, so we are including the 3, and then we are going all the way to infinity. Have you guys been using this notation? Awesome. Yeah. And then if you, it can keep on extending like a chain, as many sections as you have. That's why I like to draw it out first before writing an interpretation. Okay. Is it my turn or is it your turn? I'll just do it. Okay, so we want to write the domain for this function. Well, it actually tells us right here where we are drawing these functions. So that's really all we're worried about for the domain. So I'm just going to draw this out on a number line. So we have -5, a -2. I'm just writing down like the endpoints of the ranges here. A 4, a 2, and a 6. So looking at this, thanks. Okay, so between -5 and -2 is one range, but this line right here means that it could also equal -5. So that means we're going to fill in the circle at -5, but there's not one right here, so we're going to put a hole around the -2. And then going to where we're talking about when x equals 2, it's 5 when x equals 2. So we're just going to put a point there. And then this is another range, but neither of them have that line underneath it, so we are not including the endpoints. Okay. Does anyone want to try to write this in the notation?
I just have a question.
Mhm.
What's the point of the x squared and 2x5 on the side?
Yeah, we don't really need to know that for just trying to find the domain. That would just help us graph it if you were wanting to graph it.
If that's what's going to help us find the y values, but right now we don't care about the y. The domain only cares about the x.
Yeah.
Yes.
I may have gotten ahead of you guys. Never mind.
Oh,
I was gonna ask a question about something. Yeah.
It would just help you graph it. But we are only focused on, okay, for what x's is this function really at? Okay. So for this first interval, how could I write it? Yeah.
Could it be a bracket and then -5 because it includes -5,
Mm-hmm.
and then it would be comma -2, but a parenthesis because it doesn't include -2.
Okay. And then we go on to the next one. So we're gonna put a U here. And when you type this in, there's like a little pop-up that you can click the U on. Brackets
And then
around.
this is what I had a question on.
Mhm.
Because it is just 2 and
How
it's
do we
not
do
in
that?
between -2 and 4,
Mm-hmm.
would it just be a bracket with 2 inside of it and then another bracket?
exactly.
Because I originally had it down as -2 and then a parenthesis for -2 and then 2 and then a bracket, and then I added a whole extra section. And then I realized that it wasn't the entire section, it was just the one number.
Is that one a bracket or a set though? I thought that one was a set with like a squiggly line.
So
'Cause it
these
used
are just another way of writing sets.
to-
So
Okay.
what we're doing is, so it's like this would be equivalent to writing these with the squiggly brackets and just has 2 and everything. It's just a different way of writing sets.
Okay, so which one would be correct?
On the CBE, I think they want this one.
Yeah, they only do parentheses and brackets. Brackets
Okay,
is
so that would be the bracket, okay,
Mhm.
not the set lines.
And we use these for the real numbers, because when we have what you're talking about with the set notation, that it wants you to like list individual elements or things like that. In the real numbers, we can't list all of the real numbers between 2 and 4. We just can't. So we just use these because it's convenient.
Okay. So this would be what the last range would look like because we're not including 4 or 6. So there's parentheses. And that is what it looks like typed out. Okay, we have 2 more problems, guys. We are 5 minutes over, so if you do need to leave, go ahead and feel free to do so. And then we'll do some questions at the end. Okay, you got this? Remember what we just talked about? Domains, what we can't include.
Okay, so this says to use interval notation to write the domain of H. And when it says write the domain of H, what it's saying is write the largest possible domain. What are all of the x's that you could possibly stick in this thing and get out a real number? That is what you're asking. Can you stick an apple in there and get out a real number? No. So, because I don't know how you plug an apple into an equation. But I'm sorry, I use humor because for me it makes it fun and wakes me up. If that confuses you, I'm sorry. Okay, so basically what we're doing, so normally we just assume that the domain is all of the real numbers unless there's some reason why it couldn't be. And so that's why we're looking for those exceptions. So what are the exceptions that we have to look out for? Yes.
If we make the denominator equal 0.
Exactly. I also saw a hand over here.
Yeah, there's the same thing.
Okay, any other? Yes.
So with the square root, it can't be a negative number inside the square root because then it would be imaginary.
Exactly. So denominator not equal to 0. Square root that thing inside, not the actual square root itself. Square root is greater than or equal to 0.
Because you can have a square root of 0.
Yeah.
But what would happen if the square root is on the bottom of the fraction? What could we put inside there?
Isn't it only greater than?
Just greater than, yeah, just
Yeah.
positive numbers, not 0, because then we'd be dividing by 0.
Because then you're basically just combining these two.
Putting those together.
But yeah. And then the other one is piecewise. So if it's piece, is that how you spell piecewise?
Piecewise is just like the one we just did, basically.
But is that how you spell it?
I think so.
Okay, cool. But yeah, so this one is not piecewise. The one we did previously, that was piecewise. But that's a whole different thing. We're not worried about that right now. Right now, we are looking at these two things. Denominators can't be equal to 0, and the thing inside the square root is greater than or equal to 0. Okay, so which piece do we want to look at first? Yes.
Let's just do the square root because it's uglier.
Perfect. I love doing the ugly things first. It makes our life easier as life goes on. Okay, so we're gonna have the square root of 8x minus 3. And here, do we want it to be, so normally it's greater than or equal to 0. Do we want to use that? Do you want to use something else? What symbol do I put here?
Well, we don't want it to equal 0.
Exactly.
So,
Because it's the denominator, that would be big problems. So we are going to do strictly greater than 0. Okay. And what? Okay. So yeah. And oh yeah, I'm sorry. It's not the square root, it's the thing inside the square root. Thank you.
You can just square both sides.
Yeah, it works either way. But
So if you square both sides, will it just stay 0 on the right side?
Yep. 0
Yes.
squared is 0. 0 times 0.
yes. And yes. Okay, so then this thing inside the thing can't be equal to 0. And so then we're gonna have 8x is greater than 3, because we're gonna add 3 to both sides. And then x is greater than 3 over 8. Okay, so here's our first constraint. X is greater than 3 over 8. Okay, now we're gonna look at this denominator. 6x plus 5. So that means we're gonna have equals 0. 6x equals negative 5. X equals negative 5 over 6. Okay.
so
Yes.
already because that's negative, it's less than 3/8. So that's already not an answer.
Thank you. That is what I was literally just about to say. Okay, so then what Evan is pointing out is that negative 5 over 6 is less than 3 over 8, which is less than x. So then we can just kind of look at that and be like, well, if it's less than 3 over 8, well, if it's less than negative 5 over 6, it better be less than 3/8. Otherwise, math has failed. Yes.
Isn't it greater than or equal to 3/8?
So it would be, except for that this is in the denominator. So this is in the denominator as well. So it can't equal 0.
Okay,
So that's why it's strictly greater than.
because I thought you said that a square root of 0 wouldn't be a problem.
Square root of 0 is not a problem, but dividing by 0 is a problem.
Okay.
So if the square root was on top, then it would be greater than or equal to.
Mhm.
But since it's on the bottom, it's just-
So this one is special because it's combining both of these problems.
Yeah.
It's like, hey, I want to make you the biggest headache that I possibly can, so I'm going to do everything wrong. That's what that thing does.
So can I say two things? When I
Yes.
do these problems in my mind, it's always hard for me to remember at the end after solving it, whether what I solved for is what I want to include or what I want to exclude. So I like how she did it in here. She solved for what she wants to include. It's greater than, it's the positive numbers we want. And then, but this is on the equals thing, x cannot equal this number. So how I usually remember that is I like to write x can't equal, just so I don't like include that point.
That is
And then
good.
yeah, I was gonna just say I always draw it out so that you would have come to this conclusion even if you didn't realize it. The conclusion that you don't need to really talk about this number because it's already in the part we're not including.
And then, yeah, I think that there was like, all of this no, because it's less than 3/8. That is why I'm writing that. And we can go back to okay, and here we have a whole because 3/8 cannot be included. It can't be equal to that. Am I going to go all the way over there? So am I going to write that? How are we going to write that? Yes.
So it would be 3/8 and then infinity with the, yeah.
Exactly. We pretend that we know that we can talk about infinity. Infinity is not a number. But that's okay, because we can do math. Yes.
Why would it be a parentheses instead of a bracket for the 3/8?
Is there are we including 3/8? Is there an equal sign here?
I asked a question about it being an equal sign.
Yeah, there's not a line there. So that means we're just talking about grading.
So if you're going to so confused with that, we can
right.
plug it in. So see how it has this square root of 3/8 minus 3? So if we plug 3/8 into that, then what are we going to get?
It ends up being 3 minus 3.
3 minus 3. Square root of 3 minus 3, which equals 0. And we're like, oh, well, that's fine. Square root of 0, that's all cool. But then we look at the bigger picture and we realize it's in the denominator.
X minus
Then
2.
we're dividing by 0. When we divide by 0, the universe explodes, so we just avoid it.
Dr. Brown was talking about how educators explain why we can't divide by 0 and we can never actually explain it. We just say math experiments.
People are still working on that problem.
Yeah.
Actually, I don't think anyone has anymore.
It's just basically because of the axioms and math and stuff. Okay, last
If you
problem,
find a way to
guys.
divide by 0, let me know.
Yeah. This one's not too bad. We're just evaluating. So the only thing that might mess you up is like, what does that mean? Well, you might have like in high school used a y there, but now we have this other notation so that we can show when we want to plug in something for x. So if you see a number here instead of x, that means you're just going to replace x with that number. So 3 times 2 squared minus 4 times 2 plus 8. And now we just do some math. So 2 squared is 4, 3 times 4 is 12, minus 4 times 2 is 8, plus 8. Minus 8 plus 8 is 0, so then we just get a 12.
Yay!
Thank you guys for coming today.
There's one more.
There's one more?
Yeah,
Okay.
part 2.
Part 2. Oh.
Yeah, it's technically 10 problems for one. It's
Okay.
super fast.
Okay.
Don't worry.
All you do is plug in x plus h for x. So don't be fooled. This x here is a new x. So replacing this x with the whole x plus h squared minus 4 times x plus h plus 8.
And
Okay.
that's it. You can just leave it like that.
You go?
Oh, yeah.
Oh, cool.
Wait. And does anyone know what that would be? Just, it's okay if you don't. But does anyone know what this would be if you had x plus h, for example?
I don't know what you're asking.
It's just a transformation. All I'm getting at is like when you're doing this, if you have like x plus a number, you're taking your function and then you're just moving it. Just like, hey, I have this nice little parabola. I'm just gonna move it 4 units to this side.
You'll learn that in another CBE.
It doesn't, yeah. It doesn't matter yet. It'll come up later, but just
Good having you.
that.
You know.
So, yeah.
Can you go back to the first one again?
I would like to work on that one too.
Yep, we were doing the first one. The first time we did it, I tried to combine them together first before multiplying by the conjugate. But now what we're going to do is on the other page, we are going to just start by multiplying by the conjugate. So this is our problem.
Thanks so much. I was just gonna say that a little bit now, so you don't have to hold notes. Figure it out.
Okay, so what is the conjugate in this problem?
2 minus
2 minus 3.
Cool. And so we're going to multiply by the top and the bottom. minus I plus, okay, FOILing. We have a 10. We have a 6I. We have, I'm trying to keep it in the same order that I usually do. Minus 6I. No. Minus 15I. Then the 6I. Then the minus 9I squared. The bottom should come to, like we did in the other problem, the middle terms should cancel. And they do. Minus 9I squared. So these two terms cancel, giving us, let's see what we can combine here. So looking for all of the I squareds that we can turn into a minus 1. This becomes a plus 9 on the bottom and the top. So we have plus 10 minus 15I plus 9. So I'm going to combine the 9 and the 10 together to make 19. And then on the bottom we have the 13. Now
I do plus 6I. So 15I plus 6I.
Oh, plus 6I. Okay, 15 plus 6 is 21. No, negative 15. Thanks. Negative 15 plus 6 is negative 5. There we go. Okay. Yep. Then we got to split them up into fractions. Okay. So like last time, we gotta, I don't know how to explain this. We gotta split it up into 2 fractions so that we have our constant and then just our 9I or 13 being added. Okay, so to add the 2I parts together, I'm gonna say that this is the same thing as 13 over 13. So there's like a 1 in front. So
It kind of looks like you're subtracting.
yeah, I
realized
that.
Sorry.
Minus 13 over 13. So it's a minus 1. And then that means that since there's 13s on the bottom, then we can do minus 13 minus 9, which is a negative 22I. And even though it's after, I'm writing it after the I, this is still our A term, and this is our B term.
Which, if we check,
Did that
is exactly the same thing as we got by the time. So the universe of math is not
I like
split.
this way better.
Yeah, that way is a lot easier.
Good luck on your CBE, guys.
I had a question with number 5 real quick. Let's see. I was getting confused on the greater than or less than after we found, I know how to find the solutions, but then how do you determine
Like,
what is the solution?
if they're
what isn't
really-
the solution?
With the really solution. Yeah, this is going back to where we can't have a negative under the square root.
Okay.
Yeah.
So you'll substitute your solutions back into their equations, and then if it's a 0, then it's not included in your.
If it's a 0, it's fine. If it's negative, it's not. 'Cause we can have a square
Okay,
root.
because you can have 0, yeah. But if it's a negative, then it's not included in the, what's it called, interval.
Yeah.
Right? Okay.
Yeah, and all we were trying to explain is that it's kind of hard to put this big old fraction into there. So we were just comparing it to what the solution of the square root part of it was.
Okay. So the solution can't be a negative or a square root, right? Or just a negative?
Just the
Just that
negative.
it can't be
Okay.
So I have a quick question. When you're dividing imaginary numbers, I had a question on my assignment from like a week and a half ago.
I'm gonna end the call.